This video is about doing fiber design using a software called Telecad GIS. Here's the link to the website. You can download a free trial version of it, and it runs on top of Civil 3D, so you'll need Civil 3D and to download this Innova software. It is limited, so you would have to purchase it if you really wanted to do much with it, but you can get enough to just kind of get a trial basis of it. So with that said, let's take a look. Here we are in the software, and as you can see, it looks a lot like Civil 3D, because that's really what it's built on top of. So if you're familiar with Civil 3D, navigating around some of the objects in here is rather intuitive. I've already loaded in a design. You can do FTTX, and in this case we're going to do a transport network, which is building to building, and basically what we're doing is we're going to take this building Olin, and we're going to connect it to using existing fiber that is already part of the plant. We're going to connect it to this building right here, CCDC, the Computer Center, Data Center, and also we're going to connect it to the Snyder Phillips Hall. What these are segments of fiber that are already existed. As you see as a highlight, you see the segment. So we're going to have to take it in, so it'll go into a building and then out of the building and then into a building. So in the buildings it's already spliced, so we'll have to figure that part out as well. So let's get started on that. So some things I already did here to get a jump on the video, but these are so with any building any fiber design with this software, you're going to need the fiber paths are the most important thing. So, and that's probably going to want to be a very accurate path between buildings. So that's bringing in existing field data or something. In this case, these were shape files that we have in our database, so I just did map import and brought in each one of these shape files. So that gave me the paths between buildings, because we already have that well documented. In some cases that might not be the case, so you may have to draw your paths in, depending on where you are in your fiber plant development. But these are brought in, these are CAD objects, but we need to convert them to what they call TCG objects, so that the software knows how to deal with them. So we can just go ahead and select one of them and then do select similar, and that will select, well, it should select all of them, but sometimes it works, sometimes it doesn't. Sometimes you gotta get in here. There it goes, probably because they were different legs. But anyway, so now with them all selected, you can come on over to fiber routing tools, and then what this is going to do is it sees that we already have selected them. So basically all this tool does is converts these into a path that the software knows how to deal with. So we've already selected them, so we do next, and then you can go ahead. I always just delete that just gets rid of the CAD objects, which you don't really need to be tripping over anyway, so might as well get rid of them, and then finish. And you can see the lines have changed a little bit to this dashed black, so that means that you know that these are paths that the software will know how to deal with. And it changed, and it gives it a new layer here. The software is Serbian, so a lot of the language here is not quite intuitive, at least if you're from the US. But after a while you get to kind of know that Trasa means route, and there's other things that you kind of pick up on. It's not that bad once you get used to it. So what we need to do now is show our fiber splice points in the buildings. And for instance, this, and you can manipulate these, because I know the splice point actually in this building is actually more closer to this. So you can go like this. This is more for kind of showing the outside plant, not like a super duper inside plant route kind of stuff. As long as get the route pretty good, so you get your cable footage is pretty good. But I do know that this terminates over in this area and it not in that spot, so I dragged it up here, give us a little more room also. Next thing we want to do is set our fiber patch panels. So come over here, grab a patch panel, and click it in there. And as I'm doing these, I like to label these. So once you get a whole bunch of these in here, it helps. We'll see in the end, and then it does put the label above it, and you can move it around, which is nice. So that lets us know that that's the patch panel for this building. And next thing we want to do is, then we'll just do this for all of these buildings that we want to, that are actually on the part of where we're going to actually have to visit, because you'll see here that some of these buildings the fiber just passes through and it's already spliced in, so we don't even need to visit. The technician who's building this out doesn't even need to go into Linton, for example, because it'll just be spliced through. And I'll pull up a splice chart here in a second to give a little bit better visualization of that. But here we'll call this one's name is 1, and then Snyder Phillips is our only other one that we're going to need to actually visit. Patch panel here. So here's a look at the fiber splicing of the existing fiber plant, and we're dealing with Olin, so we see that it is terminated in Olin, but through the other buildings on the red tube it's already spliced all the way through. So we don't need to visit. And as far as this exam or design, because this is just to get the circuit from Olin to the two T1 buildings, so we don't need to, all we just need to do is show a splice on our diagram that the red tube splices through there. So let's look at how we can show a splice in each one of these buildings. So at least when we look at it, we can see from the outside plant point of view that the cable does travel through these buildings. So it's nice to be able to note that it is actually in the building. So we can show a splice in each one of these buildings. So it goes from Snyder Phillips to Student Services, and then we can grab a splice here, which I believe is this one. Yes, fiber optic splice. And there we go. So we show the splice, and then we'll give that splice a name. And then just keep going around each one of these and putting a name on it. So I'll go ahead and get all those splices laid in. Now with all the splices made, it's time to add the fiber. So we'll come to our first T1 building, we'll select the fiber, and then we'll select the patch panel. And if we get a red mark in there, that's good. So then it went to Student Services, so we'll select the splice and see how it places the fiber in there. But since this is a leg, so we'll just keep right on going. So we'll go from Student Services to I believe it's Berkey, right? We went from Student services, yep, Berkey. So that's the way we'll do it here. And I lost focus when I went to the other thing. So starting again here. Grab it here. So Snyder Phillips, student services to Berkey. Berkey to Old Hort. And then Old Hort to Olin. And we can stop here because that's, and then just right click and it adds the fiber. Sometimes it's hard to see. You can do this and you can see it a little bit better. It widens it out. So this is the one part of the leg that goes from Olin on that red tube that breaks out in Olin, and then it's spliced through these buildings and ends up at Snyder Phillips. So we will have to go in here and show the splicing for our just for the purposes of documentation when we show the schematic. So we'll have to adjust that in a second. But let's finish up with what we were doing. So once again, we'll start at Olin, go from Olin to Linton to Ag Hall, and then Ag Hall to Computer Center. Right click. And okay, so we've got both legs. So we've got a leg going this way and a leg going that way that go into the so the tube is spliced. And then it breaks out the red tube, and then it's spliced through these buildings. So now let's go through and assign the strand count to the fiber. So right now, if we click on the fiber and have a look at it, you can see it's in this cable type, fiber type. There's essentially not saying, giving any information about it, but we can fix that since this whole cable is the same. The same cable just spliced through. What we do for one will work for all of them, so we might as well just go ahead and select them all so we don't have to do this for each segment. So I'll go through here, I'll select the cable like this, and then we'll go up next to custom, click on this. Oop, not quite sure what happened there, but okay, we'll go to custom, select this. Okay, and then number of buffer tubes is 12. And number of fibers is 12. It makes for a 144 count fiber, 12 by 12. So, okay. And now we have a strand count, so as you see that it's highlighted and it's actually telling us 12 by 12 fiber. So now that we have the fiber in, we can go start in the buildings. Now each one of these, by the way the software is, so if we try to look at the splice count in this building, for instance, it doesn't show anything, and that's because we need to cut the infrastructure. I'm not quite sure honestly why they developed the software like this, but this is the way to get it to work. So you have to cut the infrastructure, so we select this, cut infrastructure, and I want to make sure I selected it. So I think it was already highlighted, so we'll cut the infrastructure. And then we just come up here and then we double click inside of it and then cut. So that has cut the infrastructure for us. But in the process of cutting it, it also put another splice in there. So we'll just select the top and delete it and get rid of that splice. And then we can come in here and select. Now we can see that we have the fiber coming in and the fiber going out. So this was the one going over to the T1 building, and then this was the one going over to Berkey, continuing on. At this very second, they're just like, it's just like a cut fiber laying in the fiber room. So it's not connected, but we can, by selecting like this, we can select everything. So this side would be so that would even tell us right here. So we have here's the fiber, and this is the fiber. It doesn't really, I thought there was some way that it tells you which direction it goes. Oh, I guess you look at the color and you can tell. So this kind of burgundy color is the one going to Snyder Phillips, and this aqua-ish color is the one going to Berkey. But we don't really care, so we're just doing mass splicing anyway, so all we have to do is come up here and stay straight through. and it splices it all the way forward, and then we just accept it. And now the software has made the splice, so we're good to go all the way through that building. So that's all we need to do for that building. So let's do it one more time. And the next building we'll take Berkey, and we'll come up here. First thing we need to do is cut the infrastructure. Double click, cut, and then we're all set. By doing it, an artifact of that act is you have this spare splice on there, which we don't need, so we'll just delete that. Come over here, splice, just select, drag up from the bottom, selects them straight through, accept, and then you're done. So you've just spliced all those fibers. A lot quicker than it would do in the field, that's for sure. So I'll go ahead and run through and connect the other ones here real quick. Okay, I went through and I spliced all these. So now that what's left to do are the core buildings. So this is the T1 core building. So we'll need to splice this. Come over here, splice it, open it up, and then so when we had initially way back looked at the splice diagram, we saw that the red tube breaks out in at Olin, so we want to hook up to the red tube here at the core building. So we can just drag the module over, or drag the tube to the module and splice it. So this is, or I'm sorry, terminate it. So, and then if we double click on it, we can see that it's all the tubes or the strands over. And we can come over here, add a device, do like one, and then we'll call this CCDC router, and then we'll say this is an active device, and then if we do switch, we can get 4. No, one of these gives you 4 switch box. Yes, 4. Select OK, and then we can go ahead and select these, right click, add to the. So this is like your patching. This is kind of like simulating patching it into a switch. So I'll do like that. And actually, I just looked at the work request, and they only want 2 strands. So we can back this up a little bit. In fact, let's just do this. It'd be a good chance to see how you can get out of this. So we have to delete the patch connections, and then we can go ahead and one of these you can delete. Device. This one we can delete it. So we'll just say yes. Okay, so we can start all over again. And then add device. And one, we'll say CCDC router. And then we can say active RTR, and then we'll just do router 2, I believe will work. Oh, we gotta put 1 here. Okay, so that gives us 2 ports, that's good. Right, left, and then we'll just drag these over here like this. And there. And that connects the switch in the T1, and this will send it over to the T2. We can also give these circuit names, so we'll call, actually I have a specific naming scheme for this. Let me grab that real quick. Come up here, change circuit name. We'll have to create a new one. Add new circuit name. Put it right here. We'll call it CCDC2 Olin. Accept and use. Accept. And then it places it there. And there, that does that T1 connection. Paste it online. Well, that takes care of that. And we can go over to Snyder Phillips. So let's do it one more time. Snyder Phillips. We'll work working off of tube 7, the red tube, I believe that's 7. Yep. And then up here. So that terminates it on the splice panel. And if you want, you can double click it and you can see each one of those strands going there. And then we'll come over here and we'll say add device 1, and then we'll say this is slide by router, and then we will give it active. We'll call this routers 2R and 2 here. And grab these patch cards. Alright, select the two, right click, change circuit name. We'll have to add a new circuit name, and we'll call this one 9 by 2 1. Accept and use. Accept. Save. Alright, almost there. And now what we need to do is come on over to Olin and add in the information for that. So it's similar to the T2s. It's just going to have 2 cables coming in. So we have a cable coming in here. This is, so it's saying the last building that it came from. So not saying that it routes all the way back to, I think this one goes to Snyder Phillips, and then this one goes to the computer center. So it's only looking back to the last building, the last segment that it was on. So one thing you do have to keep track of it from that point of view. So to help keep that a little bit more in focus, really, some little housekeeping we could do here is, let's just go ahead and delete this module, and we can do this, add a module, and we'll call it module 1, and we'll say this one is gonna go, this is the one that goes to CCDC, so we can give it a name. And then the interface, we can just say it's SC polish connectors, number of ports 12, because we're only dealing with the 2. And we can clone it like that, and that will give us 2 of them. And then just come over to this one and then edit, and we'll change the name to Snide. Like that. There we go. Okay, so at least now we know that this one, this tube right here, we gotta give it a name. That's CCDC, Computer Center Data Center. So next, we will just pull this over here. Let that terminate on that, and then this tube terminates here. And so that's the red tube for this particular leg of fiber breaks out at Olin. So we're essentially just showing the way it it is in the field right now. We'll add a device. We'll say number 1. We'll call this Olin router. And then we'll say this is going to be active. We have to use switch box on this one, so this way we can get 4 connections. And okay. And so we can actually do this and do them all at the same time. Yeah. Come on. Great. So now we'll take these 2. We'll connect them to the computer center, and then this side goes to the let's see, so this one, did I get that right? Old port goes to, double check that. So old port being the next one, actually I had it reversed. This one, so these are like switched around. Edit. Call this one, and this one, CCDC. Okay. And so we will give this one, so the circuit names will just populate through, so we're good at that too. So this is all set. These are connected like this and like this, so you're good to go. Another thing we can do is save this as a block in case you wanted to export it, so somebody can see it. So if we just do this, new block, and then accept, and there it is, on, and then accept. So now it's saved as a block. So what we can do is come over here, come up to this, yep, block, search it up over here, schematic, so we can just grab it like this. Probably should have been a little bit better positioned in the drawing, but anyways, it's a block, so all you gotta do is just grab it and drag it out of the way. And there you go. So now you can share the that with somebody if need be. You can do, if it's too big, you can do scale it like this and make it bigger, smaller, play with it. You can click in it, hit X, and explode it, and now you have access to all the elements within it if you want. So just a little nice trick. So the next thing we're going to want to do is create our schematic drawings. So this is pretty much it for our map view. And what we want to do is come up here to fiber optic schematic, and you can see right there, this gives a nice little cable diagram for us. So pretty simple block diagram, and so we can have that, but a little more detail if we come down to fibers, and this gives this one right here is similar to the cable diagram, but what we can do is come down here to settings, dynamic schematic, and then refresh, and now we have the fiber schematic diagram. It starts to give a good feel for what's out in the field right now. So the 144 cable leaves the computer center, comes along. We're using the red tube, which is going to be right here. Fibers 73 and 74. You can see it's hooked up to the router, so it's just kind of showing how it goes through there. The rest of the fibers are just spliced through, even like this. And looking at this schematic diagram, probably what we should do to make this as real as possible is we should go over to Olin and splice these other fibers through, because that's what they actually do. They only break out on the red tube, which is shown here. And I believe you can do the legend, and you can bring the legend out here like this, and show it as well, so you can bring it into the schematic. But I think what we'll do, everything else looks good. This is pretty realistic as it looks in the field. The circuit is spliced through the other buildings. So let's just visit. I think you can get at it like this. Double click it in here. Yep, we can bring that up, and we can splice the other ones through. So really all we have to do here is we can drag the tube down a little bit, get into this, straight up, and so you can just take the tube and bring it over into the splice box like this, And this will just allows you to splice it all together. This is like an infinite splice box, so anything you bring over here is going to get spliced to the whatever you bring over to this side. So you gotta get it lined up like that. So there we go. So now it's spliced everything like this. The blue is spliced to the blue, for instance, like this. So it just goes in and out. But the red is spliced up here. So how it ends up looking like this. And you can bring it back up and see that a little clear. So the reds are broke out, the other ones are spliced through, so we'll just save that. And then this will have to be oh, we did it in real time, cool. So that looks a little more realistic. So our red tube, so it's saying the fibers within the tube, so the 3 through 12 fibers within the tube are still available, which is fine because they're broke out for other connections for the building. But the rest, but the fibers 1 and 2, blue and orange, are broke out and go up to a router. And the rest of the fiber tubes that go through the building are just spliced through. So this is just kind of saying that right here. So once again, this would be another one that I would want to save as a block and include in the documentation. So that is under this little guy right here. And then we'll say new block. And accept. And it says a block is created. You know what we didn't do? We didn't bring this in, which is nice to have. For the drawing, you can change these colors if you're not thrilled about the colors, because there's not. One thing I don't like is the software always chooses two colors that are really close together. Whereas I would like to have something kind of a little more distinct. So you can say change it to like red, and it changes it to red, so you can really see the contrast between the two circuits. I don't really worry about it too much because I usually end up editing a little bit of this in AutoCAD. Once I'm done, I kind of play with this a little bit. But just to let you know, if you want to, because another thing that you can do is just come right over here and do a simple print, and then go ahead and you can just print it to PDF, so it's going to print what you see right here in PDF. So you would get this, so you could just send this over to somebody real quick if you wanted it, and so you have your legend here and it picks the colors. Well, that's another way if you don't want to go the AutoCAD route. I'm going to go the block route because I want to include this into a design package. So we'll just save this one more time because I added the circuit legend. So we'll just do this new block. We'll say Olin schematic, and then we'll call it accept. And we have it created, and now we're good. And just like before, it's under TCG view. Come over to block. You'll find what we were, the 2A. Yep, that's the one. And then we just drag it over here. And what I'll end up doing is importing this into another package that I have. So you can explode it. Once you explode it, you can have access to everything. And one final thing that you can do is you can actually even take it down to the every strand level, and that's done by accessing here fiber optic network diagram. Click on that. Over on the right screen. Hang on a second. There we go. So it brings up this. It will give you a diagram like this, which is pretty similar to everything that we've already looked at. But if we hit this and show fibers, now we can see by strand. So this is the entire 144 strand cable from Olin, and then comes through here on the red tube, breaks out. So the one's like, you can, let's see if you can select that easy. Yeah, so you can actually even select on it, and it will show you its path. So from Olin comes down through these buildings. Then it would show the names of the buildings this way. So if you look at it this way, it does show the names of the buildings. And then it just shows that it connects to another router at the data center. You can do this on this one. Maybe not. Let me try something like this. Alright. Well, I thought you could select it. Maybe that's the other style. But you can select it and have it at least see how it routes through the system like that. So that is another option. There's an align here that sometimes will help align things up. Another thing we can do is simulate an OTDR trace with this software. And so what we need to do is come into we need to come in this way, run this, come back over to fibers, refresh the connectivity, and then so let's say if we like in the field we wanted to commission this fiber link. So first thing we're going to do is shoot it with an OTDR to make sure that we have a good trace. We can simulate that by selecting it, right click, OTDR trace. It's going to give not a warning, but just a notice here, and you'll be fine. And then so first of all what it's doing is it's showing the path that you're shooting right here. So this would be a map view. So you're shooting from the computer center over to Olin up here. It will show the map view all the way. It's taking into account, so it's actually looking at it in 3D. So it's taking the z-axis or the elevation data that's in this base map and showing it. So we're pretty flat around here, so it doesn't really do much in terms of elevation. But this is the one that's mostly important, and you have the attenuation. So here it's trying to simulate what you would see on your OTDR, which is pretty good. I mean, it's giving you some idea of what you might see, and so it's every time. So it's saying you're gonna hit a building here, which is ag hall, which is true. You're gonna have a little bit of attenuation as it goes through the fusion splice. Another fusion splice here. What it's seeing here is it's actually picking up the patch cable right here and into the router. So I know this isn't super realistic for an OTDR because the spacing here, so it's not relative to the it's all kind of a linear distance, whereas this distance between these buildings would be on a real OTDR. It would be, and of course the patch cable to the router would be a very short route, and this actually should look really very small, but it does give you a quick glance at what you might expect, and you could say, oh yeah, I'm gonna see a little loss here and a little loss. So there's 2 buildings and a patch cable. That's really all it's showing. It's nothing that's it would probably be pretty hard to realistically, simulate what a real OTR would look like, but it does give you, a quick metric. I like to include it with the design package, just so the technician can have some idea what they're going to see when they hook their OTDR up. Another thing it lets you do is you can grab and go like this, and so if you wanted to know the distance to, let's say right here, you could do that, and it's going to show you on this where you're at, and I think vice versa. So it'll bring you so you can move it either way, and your marker will move along. It's also really handy if they do get an event on their, let's say they really actually are out in the field shooting with an OTDR, and they come back and they say they have a huge event at let's say 250 meters. I have no idea where that's at, so so they say at 250 meters there's a huge event, if something's kinked or broken or something like that. You can put that in here, trace it, and it will show you on this right here exactly. So you could say maybe at the point of entry or something in this building, something is collapsed, and so you can tell them exactly where to look, what manhole to pop open, and see maybe what's going on. And it also shows it on here, so that can be really helpful to simulate, to have this in your software ahead of time, so when they go out and build it, and then if they report back to you, there's a problem, it's some certain length along the cable, you can come back into the software, enter that information in, and have some accurate information to help them maybe find out in the field where they need to start looking. And this can be saved as well, or not saved as a block, but you can print this out. So that's what I usually end up doing, is printing it out. Then I import it into AutoCAD and then as a block, so you can import a PDF into AutoCAD, and then I'll do a little bit of manipulating on this to make it look a little bit more realistic to what they might be seeing out in the field on a real OTDR. And that's pretty much it for the basic tips and tricks here to get yourself up and going on this TeleCAD GIS software. I think it's a really good software. If you're at all interested in it, I would highly suggest taking a look at it. You can, like I said, you can download it and use it up to, it's limited. I think it's on objects, so it's limited to like 300 objects. So let's see, just for instance, this is 100. Just to give you some kind of idea, so I selected half of the project. It was 145 objects. Let's see, 243. So I'm not sure exactly how it works, but you may be able to draw a drawing this of this size, which is relatively small, and use the software and do it for free. But I think some other features are limited as well. But it would definitely give you, you could probably get some stuff done. And you could try it out, and you can contact sales, and they would probably give you, a license for a month or something like that if you really wanted to, if you're really interested in it. The other thing is, they are really good for software support. Any problems that you have, they'll get right back with you. They'll do a video call, do a screen share, and help you solve your problem. So very good support, really good sales. So highly recommend them if you're interested in it. And I hope that helped you out, and thank you very much.